So what are combustion reactions? Well, combustion reactions are always going to be exothermic reactions. And this basically just means that heat energy is going to be released to the surroundings. Now, there are two types of combustion reactions. There is going to be a complete combustion and there is going to be an incomplete combustion. Now, complete combustion is when oxygen is in excess. Now, excess meaning that we have a plentiful supply of oxygen gas. Now, as a result of this, you're going to be producing the products carbon dioxide and water. Now, with an incomplete combustion, this is when oxygen is the limiting reagent. So this means that you do not have a plentiful supply of oxygen gas. Now, as a result of this, you're going to be forming carbon monoxide and water. Now, another common byproduct is also going to be carbon. So let's go through our practice question now. So write the thermochemical equation for the complete combustion reaction of propane at SLC conditions. Now, the first thing to note here is thermochemical equation is simply a chemical equation that has your molar enthalpy on the right-hand side. Now, complete combustion means that I'm going to be forming carbon dioxide and water as my products. Now, SLC meaning this reaction occurs at standard laboratory conditions, so 25 Celsius and 100 kilopascals. Now, the first thing we want to do here is we want to write down the general skeleton of the chemical equation. So we know propane is C3H8 from looking at the data booklet. Now, we know combustion reactions always involve oxygen gas as a reactant. Now, because this is complete combustion, you're going to be forming carbon dioxide and water. The next thing here to note is we want to balance the chemical equation. So the first thing we want to do is we want to balance the chemical species that only appears once on both sides. Now we can see here carbon only appears once on both sides. So therefore I'm going to balance carbon first. So the first thing here is we have 3 carbons on the left and we have only 1 carbon on the right. So therefore I must put 3 on the right hand side. Now the next thing we want to look for the chemical element that only appears once as well. Now in this case here, this is going to be your hydrogens. So therefore I balance hydrogen second. So we can see here we have 8 hydrogens on the left and 2 hydrogens on the right. So therefore I must put 4 on the right hand side. Next thing we want to balance the oxygen element because this one appears twice on the right hand side. So we can see here if we add them up we have 3 times 2 which gives you 6 plus the 4 oxygen for the water. So in total on the right hand side, you have 10 oxygen atoms. So therefore, I must put 5 on the left hand side. And therefore, automatically propane is going to be a coefficient of 1. So the next thing, now that we've got the chemical equation balanced, so that's going to be 1, 5, 3, and 4. Now we want to write down our molar heat of combustion. So we can now actually refer to the data booklet. So if we quickly look at the data booklet, we can see that in your data booklet, you're going to have propane as 2,220. So therefore, we can write 2,220 here. Now, one thing to note here is we also have to include the units. So that is going to be kilojoules per mole. Now, with your molar heat of combustion, we also must write down negative or positive in front of the enthalpy change. So in this case here, because we know combustion reactions are exothermic, meaning they release heat, we are going to write negative 2,220. And that is how we do combustion reactions.